Section 1.5, Solving Inequalities. Let's get crackalin'. For any two real numbers A and B, in other words, if A and B are just numbers, exactly one of the following statements is true. What can we say? Well, we can say that A is greater than B. Let me jump back this way. We can say that A is less than B. Or we can say, yes, you're saying it right in your head right now, A is equal to B. Okay? So inequalities, if we remember either from last year or the year before, or just the other day, inequalities can be written in the following ways. We can say that less than, okay, we can say inequalities are greater than, we can say less than or equal to, or we can say greater than or equal to. Inequalities are solved using the same process as the following equations. Meaning, if I have 3x plus 4 is greater than 7, we're going to solve them the same way as, so we would subtract the 4, divide by 3. The only difference is we're going to have this inequality. What's the inequality do? There are three main things that we have to remember about inequalities. They are reverse the inequality when you multiply or divide by negative. So when do we use an open dot versus a solid dot when graphing an inequality? The biggest thing has to do with open dot when we're using less than or greater than signs, which means we don't include the line, and solid dot if the symbols are equal to underneath the greater than or less than signs, and this means you include every point that's on the line. Okay? And then the last thing we have to remember is which direction do we shade? And probably the easiest way to remember is if we solve and put an equation with the variable on the left, what we're going to do is the rayed or the shaded region points in the direction that the inequality points. So if the variable's on the left-hand side, we can do this. Meaning we would get most of our inequalities where it's y on the left and then x plus 6. So now we can say that since this is pointing to the left, we're going to shade this way or this side of the y. Another thing to think about, solution set notation. What we mean is after we solve an inequality, we get a set of all x's, set of all y's, all values that are true. If my answer came out to be x is greater than 4, what we would say is brackets x is greater than 4 and brackets. What this means is this is the set of all x such that x is greater than 4. Write the inequality that represents the following sentence. We're going to say 4 less than a number. Let's call the number n. Okay, so 4 less than a number is greater than negative 28. So we know that here's our number. If we go 4 less than that, we know it's greater than negative 28. How about twice a number is at least 15? So 2 times n at least means it's that number or more. So we can say that number or more is 15. Number 3, a number increased by 7. So a number increased plus 7 is less than 5. And the last one, hit pause real quick. Do it. Okay. What'd you get? The quotient of a number and 8 is at most negative 6. The quotient, division, a number and 8 at most means less than or equal to negative 6. Alrighty, we're going to solve each inequality and then we're going to graph its solution. So number 1, we're going to take, and we need to get w by itself, so we're going to subtract the 19 over. Draw a little line. We're going to get 2w is less than negative 14. We need to get the w by itself, so if we divide by 2, we end up getting w is less than negative 7. A couple of things that we need to remember is because the inequality is not equal to, it is an open dot. So what I like to do is we'll go here and just put the number here, 7. We're going to go negative 8, and then we'll put a negative 6 here. We know it's open. Because we solve for the variable on the left-hand side, We can shade to the left because that's everything that is on this way, or less than -7. So we'll shade to the left, and there's our answer. Okay. Number 2, we're starting off with a fraction, and we want to get z. Now the problem with this is we have z and a z. So let's get rid of the fraction by multiplying by 11. So we're going to multiply by 11. So you end up getting 3z, those cancel, plus 6 is less than 11z. Let's keep with the rules that we were doing, and we'll subtract 11z onto the left, or over to the left. And if I minus the 6 over here, we're going to get -8z is less than -6. If we divide by -8, we divide by -8. When you divide by -8, we need to remember to switch the inequality. So we're going to get z, and now it is greater than 6/8 is 3/4. So we're going to go over, we have 0, we have 1. We're going to put an open circle on 3/4, and then we're going to go greater than. Number 3, let's start off by, again, moving the y over. So we'll subtract y, or 5y. Okay, and then we're going to subtract 9 and move the 9 to the right. By doing that, you get -3y is less than 6. If we divide by -3, which is attached to the y, remember to switch the inequality because of the negative, and you get y is greater than -2. Okay. So if I go here, put a -2, we'll put a -3, and put a -1. We're going to go open circle on -2. We're graphing everything that is this way, or greater than. Number 4, now we're adding grouping symbols. So when we distribute through, we're going to get 15x plus 10 is less than or equal to, distribute, 4x minus 4. Let's move the 4x to the left. We're going to get 11x plus 10 is less than or equal to -4. Now we can subtract the 10. Subtract the 10. We're going to get 11x is less than or equal to -14. So x is less than or equal to -14 elevenths. 11 goes in there one time with, 3 elevenths left over. So it's basically -1 point something. So if we put a 0, put a -1, put a +1, we know it's going to be between -2 and -1, so we'll put it right here on a closed circle, close to the -1, and we're going to say everything that is less than. So hopefully you're getting the idea. What you want to do now is you want to pause. Do the next 2. Do number 5 and number 6 by yourself. Unpause, and we can check our answers. Welcome back. After solving number 5, we should have gotten w is less than 6. So open circle on 6, shade everything less than the number 6. Hit pause again for number 6. Welcome back. Number 6, we end up getting a is less than or equal to 22. So close circle because of the equal sign, shade everything to the left of 22. Using an inequality. So what if we have a word problem and we have a movie rental company offers 2 subscription plans. You can pay $36 a month and rent as many movies as you desire, or you can pay $15 a month and $1.50 to rent each movie. How many movies must you rent in a month for the first plan to cost less than the second plan? Okay, do we have any variables? And then if we do, we have to define them. So our variable is, we need to figure out, how many movies we need to rent. And then we're comparing 2 plans. So let's call n the number of movie rentals in 1 month. Okay, so we have the first plan. What do you do for the first plan? The first plan, it just says it cost us $36 a month to rent as many movies. So we know that the first plan is $36. But the second plan says for $15 a month and then the $150 rent each movie. So we know it's $15 plus 1.50 per movie. So let's call that N. So $15, and then for every movie we have to add additional $1.50. Okay. We want to know how many movies you must rent for the first month to cost less than the plan. So if we take the first plan and we want it to be less than the second plan, going back to what we did above, we're going to subtract 15 over. Subtract 15 over. You end up getting 21 is less than the 1.5n. If you divide by 1.5, divide by 1.5, we end up getting n on the right is greater than, this way, or you could say 21 divided by 1.5 is 14. So 14 is less than n. If I flip-flop it, make it a little easier, n is greater than 14. What does this mean? So putting it in context of our problem, what we're saying is you must rent more than 14 movies in a month for the first plan to cost less. What do we do if we have no solution or all real numbers as a solution? Is the inequality always, sometimes, or never true? What does it look like? If we distribute through, we're going to get negative 6x minus 2 is greater than negative 6x plus 7. We could look at these because both of these are negative 6x. If that is confusing, I'll just move the x over. This is positive. We end up getting negative 2 is greater than 7. We ask ourselves, okay, well, is that a true statement? Well, we have a positive number on the right, negative number. Negative numbers are never greater than, so this is false, never true. If we distribute through, so we get 10x minus 15 minus 7x less than or equal to 3x plus 8. Let's move all the x's over, so minus another 3x, minus another 3x. We're getting 10 minus 7 is 3, 3 minus 3 is 0, so we have negative 15 on the left. Is that less than or equal to 8? And the answer is yes, true. We will say always true. Compound inequalities. These are inequalities that consist of two inequalities, joined by the word and or by the word or. To solve a compound inequality involving, let's start with and, we want to find the intersection of the solution sets of two inequalities. To solve a compound inequality involving or, we're going to use the union of the solution sets. And inequalities. What is the solution of 7 less than 2x plus 1 and 3x less than or equal to 18? If you subtract 1, you get 6 is less than 2x. Divide by 2, and you end up getting x on this side. There's a less than symbol, and then we get 3. So the best way to look at this is if we flip it around, x is greater than 3. And if you divide by 3 here, the sign doesn't flip, you get x is less than or equal to 6. So because it's an and, I want to find the solution set of all the numbers that are greater than 3 but less than 6. Okay? We have an open circle here, closed circle here. So if I go to 3, go open circle. If we go to 6, closed circle. Okay? Another way we can think about it is, if I have open circle, and then I want all of the numbers that are greater than 3, I'm going to shade this way. Okay? If I take the 6, and I go close circle, and then shade everything this way that's less than, what we're looking for is we're looking for overlap. And right between this 3 and the 6 is where they overlap. So our answer would be open circle on 3 all the way to closed circle on 6. Or inequalities, if we throw an or in the middle, we're going to get k greater than or equal to, move minus the 7 over, we'll get -1. Or if we subtract the 8 over, you get k is less than -5. So we want either all the numbers that are greater than or equal to -1, or they could be less than -5. What we're going to do is we're going to go open circle on -5. We're going to go close circle on -1. You want all of the answers that are less than -5, so that'd be all of those. But all the ones greater than -1, so we go there. Examples, almost there. Solve the compound inequalities, graph the solutions. So we have x greater than or equal to -2 and x is less than 3. So what we're going to do is I just created 2 graphs. Here's my work graph, and then our final answer can be brought down. So they're both are solved for x. We know that it is closed circle on -2. So we go to closed circle, and then I would shade all of the numbers that are greater than. For the x is less than 3, I'm going to go open circle, everything less than 3. Because it's an and, we want overlap. So there's overlap between -2 and 3. So bring those down. We'll go close circle on -2. We'll go open circle, and number 9. X is less than, so we're going to go closed circle on -2. Shade everything to the left. Open circle on 3. Shade everything to the right. Just bring down this whole graph. Number 10. 10 is less than or equal to 3y minus 2, and it's also less than 19. So we can do two things. We can say that this is one equation. 10 it has to be less than 3y minus 2, and 3y minus 2 has to be greater than 19. So I set up 2 equations. Or you could just leave it like this, and then we can use the plus 2 both ways from there. So if I add 2 to the 10, you should get 12 less than or equal to 3y less than, and if I add 2 to here, you get 21. Now all that's left is to divide by 3 to all 3 terms, and we get 4 is less than or equal to y is less than 7. If we need to graph the solution set, if you remember at the beginning, we go brackets. Our variable is y, so we'll draw the line, and this is the set from 4 to y to 7. Okay. With and, we're going to say our closed circles on the 4. So we go close circle on the 4. We can go open circle on 7. And from there, our answer is going from 4 to 7. Last one, if we take and throw in an absolute value. Okay, absolute value and then the inequality, what do? We'll just remember quickly that distance away from 0, both negative and positive. This inside I need to have by itself, which it is. There's nothing else on the left. So we can write 2x minus 2 greater than or equal to 4. This is a greater sign, so it's an or. Then we 2x minus 2. Flip the sign, and we set it equal to the -4. To both equations, you can add 2, we can add 2, and add 2. Keep the or brought down. We're going to get 2x is greater than or equal to 6. 2x is less than or equal to -2. Last thing we have to do is divide by 2, and we get x is greater than 3, or x is less than or equal to -1. Okay, if we need to write this in set notation, we're going to do our bracket, and we have x this time, and we can simply put x is greater than or equal to 3, or x is less than or equal to -1. Congratulations. Hey, remember, do your best, forget the rest, or Captain America might come and find you. Bye for now.